Hello, welcome back. The title of this lesson is called Calculate and Compare Mean, Median, and Mode of a Data Set. This is part 1. So the title of the lesson exactly describes what we are going to do here. We have learned that really half of everything we do in statistics when we look at data is trying to figure out where is a good center point of the data, kind of an average, so to speak, right? And we know that we have that part of the equation. Later, we're also going to be concerned with the spread of the data. So when we find the center point of the data, right, we have really 3 ways of doing that. We have the mean, the median, and the mode, and we use them all in different circumstances. They're just, think of them as different flavors of learning about our data set. So here's our first data set here. We have the number of students, and this could be the number of students taking a certain class. So one class has 8 students, another class has 8 students, another class has 10 students, 4 students, 5 students, 7 students. So the first thing I want to do before we calculate anything is to take a look at what this data visually looks like. So we have one class with 8 students, and we also have another class with 8 students. Then we have a class with 10 students, and a class with 4 students, and a class with 5 students, and a class with, finally, 7 students. So here's what our data set looks like. Now, if I asked you, where is the center of the data set, kind of like an aggregate, kind of an average of, if you had to put your finger one place on this graph that represents kind of the center of the data, where would you put it, right? Well, this is the center of the graph, and we do have 2 points to the left, and we do have 3 points to the right. So I would say maybe it's pulled a little bit to the right because we have the 3 points here, there, but not too far. I think the center of this thing is somewhere around here. And so the mean, the median, and the mode are 3 different ways of trying to represent the center value or the center tendency of our data set. So let's first calculate the mean, and we'll do the others, and we'll compare what they look like. So for the mean of this data set, what do? First, you add these guys together, and you divide by the number of data points. So we have to add these numbers together. So we have 8 plus 8 plus 10 plus 4 plus 5 plus 7. So when you add all these together, now by the way, I'm assuming you know how to add and you know how to divide, so either you can use a calculator or you can actually do column addition like we've learned in the past. When you have 8 plus 8 plus 10 plus 4 plus 5 plus 7, you're going to get a number which is 42. All right, now you take that 42 and you have to divide it by 1, 2, 3, 4, 5, 6. 42 divided by 6. 42 divided by 6, you should also all know, is 7. And so when you add them up and you divide by the number of data points, you get the answer, which is 7. So what we found is that the mean is equal to 7. So I'm going to kind of circle that. Now let's take a minute to actually put this on our chart here. So here is 7, and we're saying that our mean, which is our average value, exactly worked out to be 7. So I'll put a dot right here on the 7, and I'll put mean was equal to 7. The mean was equal to 7. All right? Next, let's take a look at the median. So I'll put a little line right here. So the median. Remember, how do we find the median? We arrange the data from the smallest to the largest, least to greatest, and we pick the middle data point that we have in our data there. So let's go ahead and arrange everything from least to greatest. So the smallest number in our data set is the number 4. So we'll put the 4 right here. And then we have a 5, so that will come next. And then we have a 7, that's the next largest number. Then we have 2 8s, so they have to go right next to each other side by side. And then we have a 10. So let me double check. So I have 4, 5, 7, 8, 8, 10. So what we have to do is pick the center of the data set. Now you want to separate it into 2 equal piles, and we see we have a pile of 3 here and a pile of 3. So we have 6 data points, so we have an even number of data points. So if we grab these piles of 3 and pull them apart, we don't have anything in the center. So if there is an odd number of data points, the median is just going to be the center number. When you separate the data, the center number of the data set is the median. But in this case, we don't have a center number. So what you instead do is something very related. What you do is you take a look at the center 2 numbers, the 7 and the 8, and you average those together. And so what you get is 7 plus 8, and 7 plus 8 works out to be 15, right? And then you take 15 and you divide that by 2. And what happens when you take 15 and divide by 2, you do the long division on that, you get 7.5. right? Now you know basically that the answer has to be 7.5 because when you find the average of the numbers 7 and 8, what you're asking yourself is, what is exactly between 7 and 8? So you can add them and divide by 2, but if the numbers are right next to each other, you know it has to be 7.5 because that's going to be right between 7 and 8. So the median is 7.5. So I'll put here, median 7.5. Right? So we'll circle that one. So let's take a look on our chart where the median lies. So here's 7, here is 8, 7.5 is right here in the middle. I'm trying my best, it's not exact. But I can basically do something like this, put a little arrow here, and I can say median is equal to 7.5. Median is equal to 7.5. So you can see right away that we calculated kind of the center value of this data two different ways. One finding the mean and one finding the median. And they're pretty close together, but they're not exactly the same. Like I said, they're different flavors of measuring the center of the data, right? And so let's go and round it out by figuring out what the mode is. The mode is the easiest one. You can often just write it down, because the mode is just going to be the number that occurs most often. It's the most common number in your data set. This occurs once, this occurs once, this occurs once, this occurs once, but the 8 occurs 2 times. So you can just write down that the mode is equal to 8. And so we can come up to our data set here, and we can put a dot right here, and we can draw a little line right there, and say that the mode is equal to 8. The mode is equal to 8. So we have mean, median, and mode. The mean was equal to 7, the median was equal to 7.5, and the mode was equal to 8. So you have really well-behaved data if your mean, median, and mode are all pretty close together. But in reality, for some of these other problems, you're going to find out that the mean and the median and the mode can be in different places, and that is because we usually use these different ways of measuring the center of your data for different situations. Usually, we use the mean when we have well-behaved data with no outliers, right? And so in this case, the mean came out to be 7. We usually use the median if we know that we have some outliers, like some data points that are really far off this chart. Like if we had a data point at like 300 or something, 300 students in a class, right? That's obviously an outlier. It's not typical of the rest of the data. Then the median would be a better representation, because when we find the median, what we're doing is looking at the center value. If we had an outlier out here, it's almost like we throw it away. And in that case, the median would be better, because when we average it in, if we average in an outlier, it's going to skew the mean toward the outlier. But in this case, we don't have any outliers, so the mean and the median are pretty close to each other, and the mode is also pretty close as well. So we know we have well-defined data, and all three of these kind of show us that the center of this data is where our intuition told us it would be, which before we did any calculations was right there, where we gestured before. Now let's take a look at problem number 2. Here we have some test scores for like a math exam or something like that, and everybody's familiar with this because we all take exams and have grades and things like that. And so here we have 1, 2, 3, 4, 5 students, and we're going to take a look at their scores. First, before we calculate anything, one student made a 93 way at the end. He was the high score, or she was the high score of the class. 92, we had another student get a 92. 90, we had one student get a 90. We had another student to get a 92. And then we had somebody who didn't do so great, maybe should have studied more, 79. Now let's talk about this before we do anything else. So here we have a situation where most of the students did well, right? Up here got A's. But then you had one student that just didn't do so well. Now, we could call that an outlier. Now it's usually more extreme than that, because 79 is almost a B. I guess it's not terrible, but it's not that great either, right? But it is an outlier when we compare it to the rest of our data points. We know that if we're going to try to figure out a middle, kind of like an average value for this, or a measure of center of our data, this is around the center of the graph. Most of the data is over here, so we know that our average or our center should be shifted to the right. But what's going to happen is when we calculate the mean, by adding up all of these grades and dividing, the single outlier that we had, even though it was only one student who had a cold or didn't study or forgot their pencil or their dog ate their whatever, they just didn't do that great that day. They were an outlier. They're not representative of the bulk of our data, but the single data point is going to pull our average down. And let's take a look at how that happens when we calculate the mean. All right, so let's find the mean. right? So we're going to add all these guys together. We're going to have the 93, and we're going to add the 92, and we're going to add the 90, and then we're going to add the 92, and then we're going to add the 79. And what does that equal? So 93, 92, 90, 92, 79, it's going to come out to 446. And of course, I'm trusting that you can add these together either in a calculator or by hand, and you're going to get 446. Now let's take that 446 and let's divide by 1, 2, 3, 4, 5. We're going to divide by 5. And when you do that, you're going to get 89.2. Now, I'm not going to do this very often, but occasionally I want to do the long division just to kind of get practice with that. Let's take a look at 446. Let's divide it by 5. We're just going to do this quick long division. We're not going to do it for every problem. So 5 times 8 is 40. So it's going to be an 8 right here. You're going to get that 40. You're going to get a subtract. You're going to get a difference of 4, and you're going to drag down that 6. 5 times 9 is 45. That's as close as you can get. You're going to get a difference of 1. And I need to keep going because I don't have a remainder of 0. So I'll add a decimal here, and that 0 can then be brought down. 5 times what is 10? 5 times 2 is 10. And now finally my remainder really is 0. And you can see that the answer we got is exactly what you would get in a calculator, 89.2. So let's go up here and see where would our 89.2 be. Here's 89, here's 90, here's 89.5. So 89.2 is going to be closer to 89. I can't exactly mark it, but it's going to be somewhere around here, right? So I'll say the mean, 89.2. 89.2. All right. What about the median? Let's take a look at the median. We have said previously that we use the median more when we have outliers, so the median should give us a better result, or we think it'll give us a better result, since we kind of have an outlier here. So let's take a look at the median. What you do with the median is you have to arrange this data from least to greatest. The smallest number here in our list is 79. And after that, the next largest was 90. And after that, the next largest was 92. But we had two 92s. So we'll have 2 of those, right? And then finally we have 93. All I did was arrange it from least to greatest, the smallest being 79, then 90, then 92, then 92, and then 93. So what is the median of this data? So the median is the center value of the data. So if you can kind of think of this as group this data here, grouping of 2 and a grouping of 2, and you pull them apart, because we have 5 data points here, we have an odd number, we really do have a center here, and this guy means that the median is equal to 92. In the previous problem, when we tried to do that, we did not have a center value, so we just take the center 2 values and average them. That's how we find the median when we have an even number of points. But when we have an odd number of points, we just read the median straight out because it's the middle value. So the median is equal to 92. So I'm going to put here that this guy is the median. Median's equal to 92. Now let's take a look at the mode. Right, let's just take a look at the data. This is the same data ordered from least to greatest. Which one occurs most often? That's the mode. This occurs once, this occurs once, this occurs twice, but this occurs once. So 92 is also the mode. So 92, we already have a dot here for the median. So in this case, the mode and the median is 92. So you see what's going on here. We have a data set where we have kind of a cluster of students that did pretty similar and had similar results. And so if you ignore the outlier completely and ignore this and just look over here, then the median and the mode both agree pretty well, right? The median is telling us that the better representation of this data is to kind of throw out this outlier and kind of focus on the cluster of data that we have here. And so a better center value of the students in the class, other than the outlier that you have, is represented by this. But if you include the outlier, then when you calculate it by adding it all in and dividing, it pulls the mean down. You see, now the mean is outside of all of the students that actually did well. So this is the average value of the class. But it looks like the teacher teacher is not doing that great of a job. I mean, if you tell the principal that the teacher has an average value of their class grade of 89.2, then okay, it's a high B, but the teacher's really doing much better than that because there was really only one student that skewed that calculation down. If you ignore that, then a better representation of the center is solidly in the A region. And if you had your outlier do worse and worse, like instead of 79, if the outlier did maybe like a 65 or a 62, then this mean would start to drift farther and farther away, and it would be worse and worse and worse representation of the center of your data. So the moral of the story is that as your outlier becomes more and more and more crazy as far as being an outlier, then the mean becomes worse and worse and worse as far as representing the center of your data. And the median becomes better and better and better at representing the real value of the bulk of the data, discarding the outlier. All right, let's take a look at one more, and we'll call it a day here. So we have some homework problems, and this is the number of homework problems the teacher assigns to the students on different days. So let's say on one day, the teacher assigns 30 problems of homework, and on another day, they assign 32 problems of homework. On another day, they assign 27 problems of homework. On another day, they assign 22 problems of homework. On another day, 23 problems of homework, and on another day, 28 problems of homework. Let me just double check myself. All right, now let's calculate the mean, the median, and the mode of this. Right? What is the mean? Right? The mean is going to be adding all of these guys up and dividing. So let's go ahead and add up 30, 32, 27, 22, 23, 28. So 30 plus 32 plus 27 plus 22 plus 23 plus 28, what are you going to get? 162 when you add that up either in a calculator or by hand. And then if you take 162 and you divide it by 1, 2, 3, 4, 5, 6 data points, 162 divided by 6, when you do that long division, you're going to get exactly 27. So what we have figured out is that the mean is equal to 27. This is the bottom line, the final answer of that. So let's put that on the chart. The mean is going to live right here at the number 27. All right, mean is equal to 27. Now, I don't see any crazy outliers here. So, I mean, I guess you could sort of think of these as out, but really there's two of them, so it's probably not an outlier. This looks more like a nice continuous band of data here. So the mean is probably the best representation of this. But let's go and find the median just to compare. Right? For the median, we need to take these numbers and arrange them from least to greatest. All right, the median, let's go and arrange our numbers from least to greatest. The smallest number that we have in our list here is 22. The next number we have in our list is 23. I'm putting a dot under these numbers to make sure that I copy them all. Next, the largest number is 27. Right? Followed by 28 right here. Right? Followed by 30 and then 32. So we have 30 and then 32. Let me just double check. 22, 23, 27, 28, 30, and 32. Now to find the median, we have to find the center value of the data. We have 1, 2, 3, 4, 5, 6 data points. So you can kind of think about it as taking a group of 3 here and a group of 3 there, split them apart, and there's nothing in the center. So what we have to do is take these two numbers and average them there. Now we're going to actually average them, but I can tell you right away that if it's 27 and 28 and you're averaging them, and when you find the average, you're trying to find what's exactly in the middle, the answer is going to come out to 27.5 because it's right in the middle. Now, you can do it mathematically to prove it to yourself. What you do is you take 27 plus 28, and when you add that up in a calculator, you're going to get 55. And when you take 55 and you divide that by 2, right? 55 divided by 2, you're going to get 27.5, right? So what we have figured out is that the median is equal to 27.5, right? So that's the final answer for the median. So let's go ahead and put that on our chart. Here's 27, here's 28. So the median is actually going to be right in between. So I'll kind of come down here and kind of draw my arrow over here. I will say median is equal to 27.5. 27.5. So the mean and the median are pretty close there. Now let's figure out what the mode is. The mode is trying to look at our data set and figure out which one occurs most often. 22 occurs once, this 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 occurs once, so there is no mode. There's no mode, because you only have a mode if one of the numbers occurs more often than the other ones. And so there's no mode at all. So there's nothing to put on the chart for mode. It doesn't have a mode, because when the data literally occurs with where everything is happening only one time, there's no duplicates, then you just write down that there's no mode. So how do these compare? Well, this data set doesn't really appear to have any outliers. It looks fairly uniform. I guess you could say there's something missing here, but really it doesn't look that bad. They look all reasonable. And so in this case, the mean is 27 and the median comes out very, very close to it at 27.5. So when you don't have any outliers, the mean and the median very often will be close to each other, but they won't be often exactly the same number, but they'll both be pretty good representations. But if you do have an outlier, then you probably don't want to average it in, because otherwise you're going to get the situation that happened over in problem number 2. If you have a known outlier, then this mean is going to start drifting farther and farther away from the bulk of your data, depending on how extreme and how bad that outlier actually is. So if we have an outlier, this is why we want to use the median to take a look at it. And this is why when you see people talk about salaries, like how much money people make in a year, or how much a house costs, like in a neighborhood, you don't usually say the average house price or the average salary. You usually talk about the median, because if I'm living in a neighborhood where most of the houses are like, let's say $80,000, $100,000 for a house in the neighborhood, but then there's one person at the end of the neighborhood who has like a $50 million house, he's super rich and he just loves that place. Well, if you average in that $50 million or $10 million house, then it's going to skew the mean so far away from the bulk of your data that it's going to become meaningless. It's not going to be a useful measurement of the center of my data set if this one point is allowed to pull the mean far away. So usually when you talk about house prices, you talk about the median house price. So if there are any outliers, we kind of throw them away and we just look at the middle value. That's why we do it that way. So that's the thing I really want to get across to you in this lesson. The mean, the median, and the mode are just 3 flavors of trying to figure out a good way to represent the central tendency or the center of your data set. Where should you look there? And if the data is all reasonable, then the mean, the median, and often even the mode are all pretty close together. But if you have outliers, then of course the median will be better, and in general the mean will be what we use in most other cases when the data is well behaved like this. We'll just typically calculate the mean. Although you could use the median here, but usually we would use the mean if there are no outliers. So I'd like you to solve all of these yourself. Follow me on to part 2. We have 3 more examples to compare the mean, the median, and the mode of a data set.